Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. So, recently I'm just occupied with a little more work because the work at the center is still in progress. Uh, I started areas related to circles, but I have not still finished it, meaning it's not completed in full. Then I think last two classes I was doing heights and distances. For that I have the presentations ready, but I still have to do the aligning work and make the PPT. I just have the Word files. So since the files are not ready, don't worry, children. I'm just a little more occupied these days. So that's the reason. Otherwise, I remember that areas related to circles and heights and distances. So I've not done anything much. I think some 4, 5 sums, and then I sent one assignment to you. So all that is in my mind. Now, all of you have learned similar triangles in school? Raise your hand. Have you all learned similar triangles in school? Okay, so all of you in the class today have learned similar triangles at school. Fine, so we are good to take a test or some sort of a revision. All right. Yeah. Yeah, let's begin. See the first one. Let's work it one by one, meaning you work the first one, we'll discuss the answer and then move on to the second one and so on. Yeah, do the first one, children. Take down the question. Take down the question and try the first one. Okay. Taken down the figure and the question, children.
Yes, ma'am.
Okay. All right. Okay. So in this, so if I zoom in, I cannot annotate. So I have to have it in the normal mode. So from in the figure, it's given that AC and BD are two line segments meeting at P. AC and BD are two line segments meeting at P. All right. Um, Find angle PBA. PBA. This angle. Find this angle. Okay. Find angle PBA if AP is 8 centimeters, CP is 3 centimeters, DP is 6, DP is 6, and BP is 4. BP, this one is 4. This one is 4. All right, children. So we know that to find now it's not easy. It's not possible to find angle PBA from triangle ABP from this triangle because we know only one angle in that triangle. Of course, when you know two angles, you can find the third angle by the angle sum property. So you know only one angle of the triangle APB. Okay, and we have to find angle PBA. So it's not possible to find because you know only one angle of the triangle. So we need to take the help of similarity. So prove that the two triangles you see here, APB and DPC, prove that the two triangles are similar. And once the triangles are similar, the corresponding sides are proportional and the corresponding angles are equal. In two similar triangles, when two triangles are similar, in two similar triangles, the corresponding angles are equal. Corresponding angles are not proportional. Corresponding angles are equal. And the corresponding sides are proportional. When the triangles are congruent, they're identical. When we say the two triangles are congruent, they're identical triangles. Identical meaning one is just like the other. So when two triangles are congruent, their corresponding angles are equal and their corresponding sides will also be equal. When two triangles are congruent, corresponding angles equal, corresponding sides also equal because they're identical triangles. But when two triangles are similar, the corresponding angles are equal. In two similar triangles, corresponding angles are equal and the corresponding sides are proportional. All right. So how do we prove that the two triangles are, similar? Now, what are the line segments given, children? See, let me look at the two triangles. One we have APB, okay, and the other is DPC. Now, what do you know? In APB, you know AP is 8. Okay, and in this triangle, you know that CP is 3. Here, you know CP is 3. And in this triangle, you also know DP is 6. And here, you know that BP is 4. BP is 4. All right. So now find the ratio. So you do not know the corresponding sides, but you'll have to find the ratio of the sides here. So how do we do that? See here, what is 8? What is 8? This is 8. AP is 8 and DP is 6. In the first triangle, the side AP is 8 and the second triangle DP is 6. What is 8 by 6? 4 by 3. Again, see, you should in the numerator. You have two triangles. So you have to take the sides of the, for any one, take anything as the first triangle and the other one as the second one. So take the sides of the first triangle in the numerator and the second triangle in the denominator, or the other way around. But you should have the sides of the same triangle in the numerator and the sides of the other triangle in the denominator. Any triangle can be taken first. You must have the sides of one triangle in the numerator and the sides of the other triangle in the denominator. That's what it is. Okay. So now if you take this one as the first triangle, APB as the first triangle and DPC as the second triangle. Okay. So now see 8 by 6. 8 by 6 is, see, this is the first triangle, second triangle. 8 by 6 is 4 by 3. And here, see, this is also 4 by 3. So here AP is 8, here DP is 6, and here BP is 4 and CP is 3 here. APB, DPC are the two triangles. AP is 8. This is of the first triangle, AP. Side AP is 8 centimeters. In the second triangle, DP is 6 centimeters. In the first triangle, BP is 4 centimeters. In the second triangle, CP is 3 centimeters. Now write the ratio. See here, this is the side of the first triangle, AP, by the side of the second triangle, DP. What is it? It's 8 by 6, which is 4 by 3. Now write again the side of the first triangle, BP, and side of the second triangle, CP. What is the ratio? 4 by 3. And we see that the ratios are the same. AP by DP is equal to BP by CP. See here, the numerators are the sides of this triangle. And the denominators are the sides of this triangle. Okay, so AP of the first triangle by DP of the second triangle is equal to 8 by 6, 4 by 3. BP of the first triangle by CP of the second triangle is equal to 4 by 3. So what do you observe? Don't write anything. You observe that AP by DP is equal to BP by CP. So corresponding sides are proportional. And see the included angles. Which are these sides you have taken? So in the proportion, we have taken this side by this side and this side by this side. So we have taken these two sides of the first triangle and these two sides of the second triangle in the proportion. This is the proportion. This is the proportion. In the proportion, we have these two sides of the first triangle and these two sides of the second triangle. Clearly, these are the included angles. These are the included angles. In the proportion, which is the proportion, this is the proportion. In the proportion, see, we have AP and BP, first triangle, and we have DP and CP, second triangle. Okay, so now for these two sides, this is the included angle in the first triangle. For these two sides, this is the included angle in the second triangle. So the included angles are equal. Vertically opposite angles are equal. So included angles are equal. Angle APB of the first triangle is equal to angle DPC of the second triangle. So by SAS, similarity criterion, the two triangles are similar. That is, triangle APB is similar to triangle DPC by SAS, similarity criterion. Because the corresponding sides are proportional and the included angles are equal. How do you write the proportion? You'll have to take two triangles, the sides of one triangle in the numerator, sides of the other triangle in the denominator. The ratio should be the same. Choose the sides accordingly. Choose the sides accordingly. So now the two triangles are similar. And what is the result when two triangles are similar? So these two triangles are similar by the SAS similarity criterion. So now that the triangles are similar, their corresponding sides are proportional and their corresponding angles are equal. Their corresponding angles are equal. See, we are concerned about the angles because we have to find angle PBA. Okay, so now how do you write the order? Once the triangles are congruent, how do you write the order? That's very important. So you can write from this proportion itself, children. You can write from this proportion itself. See here, AP, just change this to PB. See, BP, PB, they are the same, no? BP, side P, side BP, side PB, both are the same. That doesn't make any difference. Side AB, BA, both represents the same side. Okay, and we know that the numerators are of one triangle, right? So see here, AP, it's BP, no? Make it PB. And in the denominator, you have DP. Make this PC. So APB, DPC. AP, see it's here, APPB, APB. Similar to, see the denominator, DP, PC, DPC. It's not DPPC, TPC. DPPC, DPC. APPB, APPB, APB, APB similar to DPC. So that means angle A of the first triangle is equal to angle D of the second triangle. Angle P of the first triangle is equal to angle P of the second triangle. Angle B of the first triangle is equal to angle C of the second triangle because their corresponding angles are equal. So angle A is equal to angle D. Okay. Angle A is equal to angle D. Angle A is equal to angle D. So that means this is also 30 degrees. This is 30 degrees because angle A is equal to angle D. Now this is 30, right? D is 30. So A is also 30 because A is equal to D. Now before similarity, before showing that the two triangles are similar, you cannot say A is equal to D. Now that the triangles are similar, you prove that the triangles are similar. So angle A is equal to angle D. So now you find the second angle in this triangle, 30 degrees. Now you can find this angle using angle sum property. Is that clear, children?
Yes, ma'am.
Yes, ma'am.
Yes,
Yeah,
ma'am.
children. See, you might have already learned it in your school. Still, just wanted to know if you have any questions. You can still ask me. Please write down. Yeah, please write down.
Ma'am, can you show the question?
I'll show you. I'll show you. Fine, fine. Just leave some space and please take down the answer. Yeah. I'll show you, Harini.
Yes, ma'am.
Yeah, yeah. Please write down, all of you. The first proportion. You must find the ratio separately. 4/3, 4/3, sure, find it separately. Then say that they are equal because both equal to 4/3. So sides proportional, include angle equal. So similar. Now that they are similar, their corresponding sides are proportional and corresponding angles are equal. So like that, you find the required angle PBA. Written, children? Done writing? Yeah.
One minute, ma'am.
Yeah, you wanted the question, no? Please do it fast. I gave you time for the question. What were you doing? Fast. Now we have to go to the next one, children. So please take a screenshot, all important questions from your examination point of view. Don't miss on anything. Please write down.
Yes. Yes, ma'am.
Yeah. Yeah. Okay. Somebody wanted the answer, is it? See, you better take a screenshot when I show so that even if you are missing on something, you should complete it later. Though I'm giving you, the required time. Yeah. Now see the second one, children. Triangle PQR is similar to triangle XYZ. It's similar. That means what? Their corresponding sides are proportional. So see there. Listen to me, children. Judge if I'm teaching you correctly now that you know similar triangles. So see here, children. PQR is similar to triangle XYZ. It's similar. That means what? The corresponding sides are proportional. PQ by XY is equal to QR by YZ is equal to PR by XZ because they're similar. So the corresponding sides are proportional and the corresponding angles are equal. That means what? Angle P is equal to angle Z. Angle Q is equal to Y. Angle R is equal to angle Z. Corresponding sides are proportional. Corresponding angles are equal. So two triangles are given to be similar. And then area of one triangle is given to you, area of the other triangle is given to you. And the shortest side of one triangle is given. You must find the shortest side of the other triangle. So now here you'll have to use the area theorem. Oh, is area theorem removed from the syllabus this year, children? Have you learned it in school?
Ma'am, we didn't learn.
Yeah, area theorem is removed from the syllabus for this year, correct?
Yes, ma'am.
Yes.
Anybody has learned area theorem in school? Yes, sir, Priyanka? Okay, let me ask Nandini. Same school, no? Tell me.
No, ma'am.
No? Okay.
No, ma'am. Were you not
Okay.
able to hear me before, ma'am?
Yeah, now I can. Now I am able to hear you. Fine. Okay, then ignore that, children. Okay. What about perimeter? Okay, this you can learn. This area is different. This you can learn. Now see here, similar to the second one, the two triangles are similar, and you're given some sides. You must find the perimeter of triangle DEF. In two similar triangles, the ratio of the perimeters is the same as the ratio of the corresponding sides. That's all. In two similar triangles, that is when two triangles are similar, the ratio of their perimeters, they are triangles, no? So what is perimeter for the triangles? The sum of the three sides. The ratio of their perimeters is the same as the ratio of their corresponding sides. Very easy. For that, to use this result, the two triangles must be similar, or you have to prove that they are similar. Without that, you cannot use this result. So here it's given that the triangles are similar. So in two similar triangles, the ratio of their perimeters is the same as the ratio of their corresponding sides. I'll show you the answer straight away. It's a very simple one. Oh, you have to write the question, right? Okay. Write in the question, children. Yeah. Third one. Tarun, are you writing?
Yes, ma'am.
All right. Yeah, children. Done?
Yes, ma'am.
Yeah.
Yes, ma'am.
All right, children. Yeah, this is the answer. Yes. I won't disturb you. You can help yourself. Yeah, done writing?
Yes, ma'am.
Yeah. So when we say corresponding sides, perimeter, you understand. Ratio of the perimeter, we understand. Now, ratio of the corresponding sides. So what is given? ABC similar to DEF. If I'm not wrong, that's the question, right? ABC similar to DEF. ABC similar to DEF means AB by, you can take any, okay, let me zoom out. See, ABC is similar to DEF. So which are the corresponding sides? See, the result is ratio of the perimeters is equal to ratio of the corresponding sides. Corresponding sides meaning it can be equal to AB by DE, or you can write BC by EF, or you can write AC by DF. Ratio of the perimeters, that is perimeter of one triangle by the perimeter of the other triangle. Perimeter of one triangle by the perimeter. So if you write perimeter of ABC here by perimeter of DEF, then you must write ABC side first by DEF side here. That ratio is very important. Okay, let me ask you now. So supposing I write perimeter of DEF by perimeter of ABC is equal to what, children? Is equal to, tell me all the three options available. Is equal to, don't waste time. Yes, come out with the answer.
DE by AB.
Yeah, or
EF by BC.
yeah,
Or DF by AC.
DF by AC. Thank you. Yeah. DF. So if you write DEF first by perimeter of ABC, perimeter of DEF, you can write any one of these three results. If you write perimeter of DEF in the numerator and the perimeter of ABC in the denominator, you must write the side of triangle DEF in the numerator and ABC in the denominator. So corresponding sides are D by AB, EF by BC, DF by AC. Anything you can write, or whichever is given to you. Like if you know D and AB, you should write this ratio. If you know EF and BC, write this ratio. If you know DF and AC, write this ratio. And perimeter will not be given to you straight away. Take this as the perimeter. No, the three sides will be given to you. So you add to find the perimeter. Perimeters may not be given to you straight away. The sides will be given to you. So add. Find the sum of the three sides of the triangle to find the perimeter. Please go through the answer. I'll give you a minute. See if you understand. Have you written, all of you? Are you all writing? All of you writing? Hitesh? Hitesh? Any questions, children? All right, next one. See the fourth one. There's a right triangle, and inside that there's another right triangle, and some sides are given to you. Find AE and DE. So see, there's so here the only thing is you'll have to show that the triangles are similar, and then write the ratio of their corresponding sides. We know that in two similar triangles, their corresponding sides are proportional. Show that the triangles are congruent. Oh, sorry. Show that the two triangles are similar. Then write the ratio of their corresponding sides, substitute the values, and find the unknowns. That's all. Do it. Fourth one, 4. Name the two right triangles in the figure. Name the two right triangles in the figure.
AED and ACB.
Yes, ACB. So Raja Rajeshwari, how will you show that these two triangles are similar? Which rule?
AA
What are the-
criterion.
Sorry?
AA criterion we could use.
Very good, very good. AA criterion, very good. Right angle, both are right triangles. So we have one angle, one pair of angles equal. Angle E is equal to angle C, and then the other one?
Angle A common.
Very good. Angle A is the common angle. Angle A is common to both the triangles, and both are right triangles. So one pair of angles equal to 90 degrees. Very good. So now the two triangles are similar by AA similarity criterion. Write the ratio of their corresponding sides, substitute the values, and find A and D. Very good. Oh, question you have not still written, children. Write down the question fast. Quickly write the question.
Done, ma'am.
Yeah. As you're writing the answer, please refer the figure. So I've written AED similar to ACB by AA. Exactly what Rajeshwari said. 90 degrees and common angle. Written portion. Done writing, children?
Yes, ma'am.
All right. So you can see here. First, I found AB using Pythagoras theorem. If you don't find it here, you will realize that you'll have to find it somewhere. So that's an obvious question. No? How do you know that you'll have to find AB? So maybe not. So don't find it. Then later you will realize that you need some side. So you will then find this. So the two triangles are similar. The two right triangles are similar by AA similarity criterion, right angle and common angle. Then in two similar triangles, corresponding sides are proportional. So AE. Now, how do you name the two triangles? How do you name the two triangles? They are similar, fine, but how do you name them? So the two triangles, without using the order, I'll just write the big one is ABC, the smaller one is AED. Okay, so now that they are similar, which is the common angle in both the triangles A? So start with A in both. Then where is the right angle in the two triangles? In the small triangle, it's at E. And in the big triangle, it is at C. Then write the third angles. Write the third angle. So it will be D here and it will be B here. Start with something which you know. Okay, so like in the small triangle, E is right angle. E is equal to 90 degrees. In the big triangle, C is equal to 90 degrees. In both the triangles, A is the common angle. Then write the third vertex, EAD, CAB. Once you write the order, then EA by CA is equal to AD by AB is equal to ED by CB. In similar triangles, corresponding sides are proportional. So that's what is here. Okay, corresponding sides are proportional. Then substitute the values given to you. You have to find AE and ED. You have to find AE and ED. All this 5, 12, and 3 is known to you. 13 you don't know. So then you have to find that using Pythagoras theorem. There should be one ratio in which you know both the values. Otherwise, you cannot find. Because in the first ratio, AE is unknown. In the second ratio, ED is unknown. In the third ratio, actually here AB is unknown. AB is unknown. In the third ratio, see, 5, 12, and 3 is given to you in the question. 5, 12, and 3 is given to you in the question. In the first ratio, you don't know AE. Second one, ED. Third one, AB. Then how can you find? You cannot cross multiply and find anything. One ratio, you should know both the numerator and the denominator. So you will realize that, okay, you can find AB using Pythagoras theorem and you'll fill that here, 13. So now you can cross multiply. You can take up the first ratio with 3 by 13, take up the second ratio with 3 by 13. That is equating the first ratio to 3 by 13 and the second ratio to 3 by 13. You will be able to find the values of AE and ED. Simple, right, children?
Yes, ma'am.
Yeah, thank you. Yeah, any questions? Any questions, children? Proving the similar is very easy. 90 degrees common angle, proportion, fill the values given. You can find one using Pythagoras theorem. You should find like that. If you can find something, find the side. It will be useful to find the final answer. All right, see the fifth one, children. Oh, area you don't have, no? Okay, so you can ignore that. Area you don't have. So do the sixth one, children. Do 6. I'll just come back. I'll just have some water and come back. Please try the sixth one. Yes, what's the answer?
My by x plus y.
My by x plus y, is it?
Yes, ma'am.
Ma'am, me too
Okay.
got the same answer, ma'am.
Very good. My by x plus y. Let me see. Yeah, my by x plus y. Very good. So again here we'll have to show that the two triangles are similar and then write the ratio of the corresponding sides. Substitute and get the result. Very good. So how do you show that? Which are the two triangles here? AEC. Yeah, AEC and BDC.
Easy.
Yeah, correct. So these are the two triangles. One big triangle AEC and the one inside that BDC. So in this triangle, in this first triangle, angle A is 48 degrees, and in the second triangle, angle B is 48 degrees. And in both the triangles, angle C is common. You can see this angle C is common to both the triangles. Angle C is common to both the triangles. This angle is a part of this triangle and is also a part of the whole triangle. So C is the common angle. Angle C is equal to, that is angle E. For the small triangle, it is DCB. And for the big triangle, it is ECA. DCB, ECA, common angle. And then small triangle, this is 48, big triangle, this is 48. So double A similarity, the two triangles are similar. So how do you write the order? A is 48 in the big triangle, B is 48 in the small triangle. C is the angle common to both the triangles. Then the third vertex, ACE, BCD. The two triangles are similar in this order. They're similar. So AC by BC is equal to CE by CD is equal to AE by BD. Okay. So what is AC? AC is x plus y. By BC, BC is y, is equal to CE. CE not required then. CD, ignore those two sides. This is not needed. Okay. Because you don't know CE, you don't know CD also we don't know. Just leave it because to find the result, two ratios are enough. You're anyways going to equate two ratios at a time. You're not going to do anything with all the three of them. We don't know anything. CE, CD, just ignore it. Ignore it is equal to AE by BD, AEM by N. And now we have to express N in terms of the others. So cross multiply. N into x plus y is equal to my. So N is equal to my by x plus y. My by x plus y. Am I right, children? Okay. So
Yes, ma'am.
similarity, yeah. So similarity, 48, 48, that angle can be anything. It will be a different angle also. But anyways, they're equal and one common angle. So double A, they're similar. Once they're similar, corresponding sides are proportional. Write that proportion. And then fill in the values, whatever is given. Now in this ratio, CE by CD, we don't know anything. Just ignore it. Ignore it, leave it. Then cross multiplying the two ratios, you should write N in terms of the others. Very simple. Very commonly asked. In most papers, you can see a question like this, except that the angle will change. 52 degrees, 56, whatever. Show you the answer. Yeah. Just wait for a minute. If you want to write down, you can. See, I have not written the information. I've directly written BCD similar to ACE. But you have to write the two triangles, and you should write in this triangle and this triangle. This angle is equal to this angle, 48 degrees. This is the common angle. So you should write all that like we do in congruent triangles. You should list the equalities or the proportion, whatever. You must list it and then say that they are similar. You should not directly write like this. Triangle BCD similar to triangle ACE AA. How AA? What makes AA? You should write that information. Done writing, children?
One minute.
All right. Yeah.
Yes, ma'am.
All right. Hmm. All right. See the next one. Oh, it's area. So you don't have. It's area. Find area of quadrilateral. Given area of the triangle. Okay. So you don't have this. What have you learned from similar triangles, children? BPT and Pythagoras theorem, converse of Pythagoras theorem, or only BPT and converse of BPT?
BPT, converse of BPT only.
That's all, huh? Nothing else.
And the similar criteria.
Okay, yeah, similarity criteria. Criteria, yeah. Then
That's all.
that's all. That's all. Pythagoras theorem, converse of Pythagoras theorem.
No.
No. Hitesh, is it?
Yes, ma'am.
Okay, yeah, all right. Yeah, okay, we are doing relevant ones only. Anyways, we are not touching anything other than BPT and similar triangles. Yeah, eighth one should. 8. Is BC parallel to DE? Now, what is a theorem you would use to show that these two lines are parallel or not? Name the theorem.
Converse of BPT theorem.
Converse of BPT. Yeah, we need to use the converse of BPT to show that the lines are parallel or not parallel. Yeah, tell me, children. Try this and tell me. Excuse me. Yeah.
Done, ma'am.
Yeah. Parallel or not parallel?
Not parallel.
Not parallel. Others?
One minute, ma'am.
Okay. Tarun finished working?
No, ma'am.
Okay. Nandini? Priyanka?
Yes, ma'am.
No, ma'am. 1 minute, ma'am.
Yeah, Nandini, parallel or not parallel? How long should I wait to get the answer from you? Some said not parallel. What about the others? For each and every answer, I have to keep requesting you.
Ma'am,
Yeah,
ma'am, it is parallel, ma'am.
it is parallel. Okay.
Ma'am, I've done it, ma'am. It is parallel.
It is parallel. Okay. Yeah, Priyanka, read out your steps.
Yes, ma'am. Ma'am, first I've written the given AB is equal to 10.8 centimeter, AD is equal to 6.3, AC is equal to 9.6, and EZ is equal to 4. And then for DB, it's for DB it's AB minus AD, ma'am. So it's 4.5. And for
Okay.
AE, it's 5.6, ma'am.
Okay.
So AD by DB is 6.3 by 4.5, and then I've got it as 7.5. Sorry, ma'am, 7 by 5.
Yeah, go on.
Ma'am, can you hear me?
Now, yes.
Yeah, ma'am. And then AD by DB is 7.5, ma'am. And AE by EC is also 7.5. So by
7.5, 7 by 5.
sorry, ma'am, 7 by 5. So by
Okay.
BPT it is parallel.
By BPT, huh? By converse of BPT.
Yes, ma'am.
By converse of BPT. Okay, Priyanka, state the basic proportionality theorem. State. Yeah, somebody state the theorem. State BPT. Actually, in every online class, I always feel I can do double the work. See, I have to ask a question and wait for 5 minutes. You know or you don't know? Can you state it or no?
Can you hear me?
Yeah. Yes, Ananya.
When a line is drawn intersecting the two sides of a triangle and is parallel to the third side, the ratio of the line segments intersected by the line segment will be of the same proportion. Ratio.
Same ratio. Okay. When a line is drawn parallel to one side of the triangle to intersect the other two sides at distinct points, the other two sides are divided in the same ratio. You can remember it the way you can just draw and remember that. Certain things you must make it, figure, meaning using a figure, you must remember. 1 second. So, triangle. Now what you have to do? If a line is drawn, see, if a line is drawn parallel to one side of the triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. Just draw like that, and you should draw that in your mind. So like a line is going through like this. If a line is drawn parallel to one side of the triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio, So sometimes you may have to state. So remember the statement. Yeah, so as Priyanka told us, we have to find AD. You'll have to find AD. AD is equal to AB minus DB. AD we know. AD is how much? 6.3. And BD is equal to AB minus AD. 10.8 minus 6.3, which is 4.5. This is one thing. Then on the other side, A is EC, okay. So AE you have to find. AE is equal to AC minus EC. AC is 9.6 minus 4, which is 5.6. And the other segment EC is known 4. Okay. So now you should find the ratio separately. You don't know if they're equal. You have to find the ratio separately. So in the first triangle, you'll have to find, sorry, not triangle. On the line segment AB, or the side AB, you have to find AD by DB. AD by DB. How much is AD? How much is DB? So shift the decimal, 63 by 45. Shift the decimal point, 63 by 45. So 9 sevens are 9 fives are. Have that ratio, AD by DB. Next, you should find AE by EC. AE by EC. AE is 5.6 by 4. So like you have to multiply by 10 to shift the decimal point. So it becomes 56 by 40. 56 by 40. 8 sevens are 56, 8 fives are 40. So clearly AD by DB is equal to AE by EC. So the two sides are divided in the same ratio. That means D is parallel to BC. Since the two sides are divided in the same ratio, By the converse of BPT, DE is parallel to BC. Okay, so that was easy. 9. Do the 9th one, children.
Ma'am,
Yeah.
ma'am, I did it by AD by AB equal to AE by AC, ma'am.
Yeah, that's fine. Yeah. But that's correct. They are the other results of BPT. That's accepted. But again, what has the teacher told you in school? She's okay with that? They are the
Yes.
other results of BPT. Yes, you can do that, but just check with your teacher also. Yeah, that's correct. AD by AB and AE by AC, or you can do DB by AB and EC by AC. That's correct. All right. Yeah, do the 9th one, children. So you'll get a different ratio. What did you do? Tell me. You did AD by AB, yeah?
Yes, ma'am.
So you got 7 by 12, right?
Yes, ma'am.
Yeah, correct. 7 by 12, 7 by 12, correct. Yeah, children, 9th one. Use the figure in question number 8 and this information to find AE. Yeah, got the answer? E.
Ma'am, 4 centimeters.
4 is it? Let me check. Yeah. Oh, for the 9th one. Yeah, you're right, Nandini. Yes, A is 4.
Me too got the same answer, ma'am.
Very good. Harini, is it? Harini Sneha. Okay.
Yes, ma'am.
All right.
Yes, ma'am. I got 4.
Okay. Very good. I'll show you the answer along with the 10th one. Now, tell me the statement. If, okay, how do I ask this question? Okay, when you look at this figure, what statement comes to your mind from similar triangles? Forget the information given A, O, C and all that. When you look at this figure, what statement or what fact about a trapezium comes to your mind?
It has a one pair of parallel sides.
No. With regard to similar triangles. Some property which you've learned with regard to similar triangles. Not in general. Meaning,
Congruency, ma'am.
sorry?
Congruency.
No. Here, no, not congruency.
Alternate interior angles.
No, not that. Okay, NCRT, I think the second exercise, the last two questions from trapezium, the last two questions, 9 and 10. NCRT, I think second exercise, last two question number 9 and 10.
One pair of sides are parallel.
That's true, but not that here. We have learned something regarding the diagonals. And that property is what we will be using here to solve this, to find x. Okay, what is that property? How will you find x, children? How will you find x?
Ma'am, if we prove triangle AOB and DOC are similar, ma'am, we can say that AO by OC is equal to DO by OB, ma'am. So they are proportional.
No,
After
AO
that,
by
we will
OC. No. AO by OC is equal to what? AO by OC is equal to?
OB
I'm just
by
coming,
OD.
children. No. AO by OC is equal to OB by OD. 1 minute, children. I'm just coming. Yeah, children. Yeah, so I was talking to Hitesh. AO by OC is equal to BO by OD. AO by OC is equal to BO by OD. So that's what you proved in this chapter. I think the 9th one. The diagonals of a trapezium divide each other proportionally. The diagonals. We have learned in standard 9 that the diagonals of a parallelogram bisect each other. In a parallelogram, see, if this was a parallelogram, O is the midpoint of AC, O is the midpoint of BD. If ABCD is a parallelogram, then O is the midpoint of AC, O is the midpoint of BD, which means the diagonals bisect each other at O. So what have we learned here in class 10? What have we proved using similar triangles about a trapezium? The diagonals of a trapezium divide each other proportionally. AO by OC is equal to BO by OD. If the diagonals of a quadrilateral divide each other proportionally, then the quadrilateral is a trapezium. We have proved these two results in 9 and 10. Question number 9 and question number 10, NCRT. If the diagonals, see, one question is a trapezium is given to you and you have to prove that AO by OC is equal to BO by OD. Then in the other question, it's given that AO by OC is equal to BO by OD. You have to prove that it's a trapezium. In one, you are given that ABCD is a trapezium. And you have to prove that AO by OC is equal to BO by OD. In the other question, you are given that AO by OC is equal to BO by OD, and you will have to prove that the quadrilateral is a trapezium. Yeah. All right. Yeah, do the 10th one, children. I'll show you 9 and 10. Well, the 10th one. Working, is it the 10th one?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah, please work, yeah. I'll just get back. Please work, children. I'll just get back. What's the value of x, children? Yeah, what's the value of x? What is the value of x?
Ma'am, is it 8 or 11?
8 or 11. Okay.
I'm getting
8 or
3.
11. Very good. What is the quadratic equation you got?
Ma'am, x square minus 19x plus 88.
Perfect. Very good. Very good. Ram, I'm happy that you've turned on your video, but I can't see you. Oh, you're somewhere there. Okay, okay. Fine, fine, fine. Good boy. All right, children, let's see the answer. 9 and 10. Yeah, 9 is here, children. Below. Please find answer 9 below.
I also got x is equal to 11 or 8.
Very good, very good. Okay, so this was the 9th answer. See the 10th one here. We know that the diagonals of a trapezium divide each other proportionally. You need to write that and then write the result. AO by OC is equal to BO by OD. Substitute the expressions, cross multiply. We'll get a quadratic equation, split the middle term, find the two values of x. And both the values of x are acceptable. Now, supposing you get x is equal to 2, x is equal to 11 or 2, supposing. Okay, so 2, you have to reject 2. Why? Why should you reject 2? Supposing you get x is equal to 11 or x is equal to 2, we have to reject 2. Why?
2 minus 3 will give a negative answer. Side cannot be negative.
Very good. Yeah, because when you take the value of x here, 2 minus 3, because OB is a line segment and its length is positive. So OB is x minus 3. And if you take x as 2, 2 minus 3 is minus 1. Which is not possible. So you have to, though 2 is positive, it does not make a meaningful value when you use it in x minus 3. Okay, can you go ahead, supposing you get a fraction, x is equal to 11 or x is equal to, not in this situation, I'm asking for some other situation, supposing you get x is equal to 11 or x is equal to half, can you reject half because it is a fraction? Or can you reject half because it is negative? Okay, so you cannot reject the values of x because it's a fraction or because it's negative. You have to always use the value of x in these expressions. You will have to use the values of x in these expressions. This is sometimes when x is supposing minus half, say minus half, and supposing the expression is 4 minus 2x, 4 minus 2x, for example, okay, or 5 minus 2x, say 5 minus 2x. Okay, there's an expression 5 minus 2x for a side. OB is equal to 5 minus 2x. Okay, and what is x here? 2 into what is x? Minus half. Minus half. So 2 and 2 gets cancelled. So 5 plus 1. See here 6. OB is 6. OB is 6. But what was x? Minus half. So when you see a negative value, we feel that it's negative and also it's a fraction. So okay, fine. It can be a fraction because it's a line segment. It can be 0.5. The length can be 0.5. But we feel it's negative. So it cannot be negative and we reject it. No, you cannot reject it on those grounds. Whatever be the value of x, you have to use that value in the expressions here. If it does not satisfy even any one of the expressions, you'll have to reject that value of x. Now here we have three expressions, x minus 4, x minus 3, and 3x minus 19. Maybe a value of x satisfies this and this, but does not satisfy 3x minus 19. You cannot go ahead with that value of x. So remember that you cannot reject a value of x because it is negative or because it's a fraction or for any reason like that. Whatever be the value of x, please use it in these expressions and see if you're getting, meaningful values for the line segment. So like that you have to reject. Not because it's a fraction or negative, not like that. It can be even negative, like I showed you. If x is minus half, it's fine. X can be minus half because when you use minus half here, it's 5 plus 1, 6. All right, children. So that's about this one. Okay, I didn't ask you one more question. Now, how will you show that using BPT? See, you can prove that the diagonals of a trapezium, divide each other proportionally using BPT and the similar triangles and the concept of similar triangles. Now tell me, using BPT, show that to prove that AO by OC is equal to OB by OD. Prove this result using BPT. Using BPT, or if you want converse of BPT, whatever you want. Not similar triangles. How will you do it?
Ma'am, we have to construct OM and M is a point on side AD, ma'am, and we have to say that OM is parallel to AB, so it is also parallel to DC.
Very good.
So by that we can say that if it is parallel and it will be dividing the sides proportionally. So by BPT theorem we can.
In which triangle? In triangle?
ADC. DC, ma'am.
ADC. Yeah, in triangle ADC. Tell me the proportion.
AM by MD is equal to AO by OC, ma'am.
Very good, very good. Which is the other triangle you'll have to take? Where do you have a set of parallel lines? You should take that triangle where you have a set of parallel lines. Now you took, okay, which are the three lines parallel? Now, because ABCD, listen children, because ABCD is a trapezium, we know that AB is parallel to CD. Now by construction, OM is parallel to maybe AB. You can draw OM parallel to AB or CD. By construction, OM is parallel to AB. But since AB is parallel to CD, OM is also parallel to CD. All the three lines are parallel to one another. So now in this triangle ADC, OM is parallel to DC. You have taken this. OM is parallel to DC. Now, where is this? Where can you use this result? OM parallel to AB in which triangle?
ABD.
ABD, yeah. So ABD, you should take ABD. Write the proportion there. Try to maintain AM by MD.
AM by MD is equal to BO by OD, ma'am.
Very good. So comparing these two, you should call this one result 1 and this one 2. From 1 and 2, because AM by MD is common. So from 1 and 2, AO by OC is equal to OB by OD. So this is how you show that the diagonals of a trapezium divide each other proportionally using the concept of BPT. You can also do it using similar triangles. This is using BPT. Trapezium ABCD given. Diagonal AC, diagonal BD intersect at O. We have to prove that AO by OC is equal to BO by OD. Construction. Draw OM parallel to AB or CD, you can say anything. Draw OM parallel to AB. But AB is parallel to CD because it's trapezium. So from this, OM is parallel to AB, but AB is parallel to CD. So from this, we have OM is also parallel to CD. Or all the three lines are parallel to one another. Now leave this one. AB parallel to CD is in the trapezium. You leave this. Now look at these two results. So take a triangle or take the triangle where you have OM parallel to AB. Where do you have OM parallel to AB? OM parallel to AB in triangle ABD. ABD. In triangle ABD. OM parallel to AB is in triangle ABD. See, the triangle is like this. Like this it is. ABD and somewhere here we have OM, like this it is. Like this we have. ABD, triangle ABD, and we have OM parallel to AB. OM parallel to AB. So by BPT, we have AM by MD is equal to BO by OD. By BPT, we have, because the lines are parallel, we have AM by MD is equal to BO by OD. Have this. This is result 1. Now take a triangle which has OM parallel to CD. OM parallel to CD. So if you look at the figure in triangle ADC. So see, you have it like this. In triangle ADC, you have you have M here and you have on AC, you have O here like this. OM is parallel to DC. So from here, using BPT, we have from in this triangle using BPT, we have AM by MD is equal to AO by OC. So call this 2. From 1 and 2, AM by MD is common in both. So from 1 and 2, AO by OC is equal to BO by OD. AO by OC is equal to BO by OD. Hence, we have proved that the diagonals of a trapezium divide each other proportionally. Now, the same thing if you have to do it using the concept of similar triangles. Similar triangles, that is easier, meaning you can do it faster. Prove that the diagonals of a trapezium divide each other proportionally using similar triangles. So like what Hitesh told us earlier, take up the triangle. So you know that this angle 1 is equal to angle 2. Alternate angles are equal because it's a trapezium, right? The trapezium, parallel line, transversal, parallel line. Then parallel line, transversal, parallel line. Alternate angles are equal. Alternate angles are equal. This angle is equal to this angle, alternate angles. this angle is equal to this angle, alternate angles, vertically opposite angles. You can say AA or AAA. AA or AAA. So this angle is equal to this angle, alternate angles. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. And then this angle 5 is equal to angle 6. Vertically opposite angles are equal. So the triangle is similar by AAA similarity criterion. So in similar triangles, corresponding sides are proportional. So when you write the proportion, you will get AO by this one is equal to this by this. If you write the proportion, you will get the result. So this is how you do it using similar triangles. Now, how will you show that if this is given to you, given that trapezium, oh no, it's a quadrilateral, sorry. ABCD is a quadrilateral, okay? ABCD is a quadrilateral in which AO by OC, is equal to ABCD is a quadrilateral in which AO by OC is equal to BO by OD. You'll have to prove that. You'll have to prove that ABCD is a trapezium. ABCD is a trapezium. Yeah, tell me how you do this. Work in your book and let me know. Yeah, work, children. If you know, you can tell me now. Yeah, done, children. So for this also, you'll have to take up the same construction. But here we do not know. Here ABCD is not a trapezium. So we don't have AB parallel to CD. We don't have AB parallel to CD. So construction, draw OM parallel to AB or DC, whatever. Draw OM parallel to DC. Now only OM is parallel to DC. You cannot say that OM is also parallel to AB. Because ABCD is not a trapezium. You'll have to prove that it's a trapezium. So here you'll have only one set of parallel lines. Draw OM parallel to DC, or you can say draw OM parallel to AB, anything. Now take up that triangle. So according to your construction, you have OM parallel to DC by your construction. Now, according to this, which is a triangle you'll have to take, children? Please tell me that at least. If OM is parallel to DC, which triangle will you take for BPT?
ADC.
ADC. In triangle ADC. Very good. In triangle ADC, because MO is parallel to DC, see, this is the ADC. If you don't understand, you should actually draw the triangle separately like this and make out. This is your construction. MO. See, this is the AC. This is AC. O is on AC. This is the triangle. So AM by MD is equal to AO by OC. Because by your construction, in this triangle, you can use BPT. Now that's all. You don't have any other set of parallel lines to use BPT. That's all you can write. Now the other thing is the proportion which is given to you, but you're given that AO by OC is equal to BO by OD. You're given this one. One you have from BPT in a triangle, the other is given to you in the question. When you compare these two, you get AM by, when you compare these two, you get AM by MD is equal to BO by OD. AM by MD is equal to BO by OD. Where is AM? AM by MD. See here? AM by MD is equal to BO by OD. So see, take the triangle. Take the triangle now. AM by MD is equal to BO by OD. So this triangle. See here? AMD BOD. Now see here, AM by MD is equal to BO by OD is given to you. Sorry, we already have that result. By comparing, we have this result. AM by MD is equal to BO by OD. So by the converse of BPT, AB is parallel to MO. By the converse of BPT, AM is parallel to AB is parallel to MO. By the converse of BPT, AM, oh sorry, AB is parallel to MO. By the converse of BPT. Now, by construction, what you have? By construction, we have OM. Construction, we have OM parallel to DC. Now we have proved that OM is parallel to AB. Construction, we have OM parallel to DC. Now we have got this result using converse of BPT that AB is parallel to OM. This is OM only. AB is parallel to OM. DC is also parallel to OM. That means AB is parallel to DC. Two lines parallel to the same line are parallel to one another. 9th standard. Two lines parallel to the same line are parallel to one another. AB and DC are the two lines. AB and DC are the two lines parallel to the same line OM. So they are parallel to one another. AB is parallel to DC. Two lines parallel to the same line are parallel to one another. AB and DC are the two lines parallel to the same line OM. So they are parallel to one another. So AB is parallel to DC. So in the quadrilateral ABCD, one pair of opposite sides is parallel. AB is parallel to DC. Therefore, ABCD is a trapezium. Okay. Please revise this from your notebook today so that you don't have to revise it for your exam. Now you've heard it, right? So it will be fresh in your mind. Before you go to sleep today, just go through this proof. Just tell it to yourself. Hardly 5-10 minutes it will take. You will not forget it at all. I have a feeling that, you know, something of this will come in the exam. Just study that. Study this. Okay, over to the next PPT. What's the time? Okay, we have some more time. I don't have the question separately, so yeah. Do the 9th and the 10th one, children. Oh, sorry. Yeah. Please take down the 9th and the 10th question and start working the 9th one. Yeah, what's the answer for the first one? I can take a nap, I think, by the time you people tell me the answer. I don't know. This year, the online class is not interactive at all. Has anybody got the answer for the 9th one?
Working, ma'am.
Okay.
Ma'am, what is the angle B, ma'am?
Angle B is it's just 30, not 130 degrees. 30.
Okay, ma'am.
Ma'am,
Yeah.
D is equal to 20 degree and F is equal to 30 degree.
20 and 30, is it? D and F? Okay. So what is the procedure? Read out your answer.
In triangle ABC and triangle DEF, AC by AB is equal to DE by EF is equal to 7 by 5.
Okay.
Angle A is 130 by angle sum property.
Okay.
So that true triangle.
The two triangles are similar by?
SAS criterion.
Yeah. So in similar triangles, the corresponding angles are equal, correct?
Yes, ma'am.
Very good. You're right, Rajeshwari. Very good. I'll show the answer, class. Do the 10th one. You'll have to prove that CED is similar to ABC. Yeah, 10th one. Shall I share the answer for the 10th one?
Yes, ma'am.
All of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Again, very commonly asked this one. Very simple also. Zoomed and so on. Okay, the numbers may vary. I'll just take a figure like this, right triangle, right triangle. Okay.
Ma'am, I got the answer for 10th question, ma'am.
Very good. Okay, just tell me if you have a different. Okay, tell me, Rajeshwari. Let me listen to you first.
In triangle ABC and triangle CED, angle ABC is equal to angle DEC 90 degree, ma'am. Angle BAC is equal to angle ACD, alternate interior angles, ma'am. So by
Very
AA criterion, ABC is similar to triangle CED, ma'am.
Very good. But how can you say that they're alternate interior angles? Which are the parallel lines? Parallel lines are not there. So you cannot say that they are alternate. They are alternate interior angles, but you can't say that they are equal. Now, see, when you have, see now these are two lines intersected by a transversal. So these are alternate interior angles, but they're not equal because the lines are not parallel, but they are alternate interior angles. These two angles are alternate interior angles. But they're not equal because the lines are not parallel, because this line is not parallel to this line. Okay, I'm happy. You're right, Rajeshwari. I'll tell you the justification. So let me tell that method first, what Rajeshwari has done. So in triangle ABC, in triangle ABC and triangle DEC, okay, in ABC angle 1 is 90. In DEC angle 5 is 90. So 1 is equal to 5 is equal to 90 degrees. Now we know that two lines perpendicular to the same line are parallel to each other. Or see now, see here, when you have two lines like this is 90, this is 90. Co-interior angles are supplementary. So that means these two lines are parallel, right? When co-interior angles are supplementary, the lines are parallel. See here, you have AB, BC, DC. You have AB here, you have CD here, 90 is given. I'm not marking, it's given. So you can see that co-interior angles are supplementary. That means AB is parallel to CD. That's one way of showing that AB is parallel to CD. Or what you can say is two lines perpendicular to the same line are parallel to one another. Two lines perpendicular. See, AB and CD are the two lines perpendicular to the same line BC. So AB and CD are parallel to one another. I'll write it here for you. Two lines AB and CD are parallel, are perpendicular to the same line, BC. Okay, so I'll write in general first, sorry. Two lines perpendicular to the same line are parallel to one another. So here AB and CD are perpendicular to the same line BC. Therefore, AB is parallel to CD. AB is parallel to CD. Like this, you can prove that AB is parallel to CD. Now that they are parallel, see here, parallel line, transversal, parallel line. Alternate angles are equal. Angle 2 is equal to angle 4. Angle 2 is equal to angle 4. So angle 1 is equal to angle 5, 90 degrees in the two triangles. In this triangle and in this triangle, angle 1, this angle 1 is equal to, I can't see the angles at all. Okay, in the two triangles, so in this triangle, angle 1 is equal to angle 5 in this triangle, 90 degrees. Then, since these two lines are parallel line, transversal, parallel line, alternate interior angles are equal. Correct? So angle 2 is equal to angle 4. Angle 2 is equal to angle 4. So AA similarity criterion, the two triangles are similar to each other. Make a note of this, children. I'll tell you the other way. Make a note of this. Two lines perpendicular to the same line are parallel to one another. AB and CD are the two lines perpendicular to the same line BC. So they are parallel to one another. 9th standard. Made a note of this?
Yes, ma'am.
Okay, so angle 1 is equal to angle 5. Angle 2 is equal to 4. Alternate angles are equal. So AA similarity criterion, the two triangles are similar to one another. The other way is, can I clear the slide?
Yes, ma'am.
Yeah. The other way is, now tell me, children, tell me the places where, the angles add to 180. Now let me write one for you. Angle 3 plus angle 4 is 90. Now I want two more results like this. Is equal to 90. I want two more results. Tell me. Angle 3 plus 4 is 90. Tell me two more like this.
2 plus 3 and 4 plus 6.
Very good.
Angle
2
6
plus.
plus 4.
Yeah, correct. Yeah. Ananya said 2 plus 3 is 90. She's right. And Sneha or Harini, I don't know. 6 plus 4. You're right. 6 plus 4 is 90. Very good. 6 plus 4 is 90. Now, I put it this way, you know. See, 2 plus 3 is 90 is in this triangle. 6 plus 4 is 90 is in this triangle. But 3 plus 4 is 90 is of both the triangles. 3 is in one triangle, 4 is in the other triangle. So use that for comparing. Use that for comparing. This is like the leader now. Why is this the leader? This is the leader because angle 3 and angle 4 are in both the triangles. Angle 3 is in one triangle, angle 4 is in the other triangle. Angle 2 plus 3 is 90. 2 plus 3 is 90. That is of one triangle. 6 plus 4 is 90 is in the other triangle. So now compare. So this is the main meaning. This is the rule like. So this is 1, this is 2, this is 3. Compare 1 and 3. Compare 1 and 3. Compare 2 and 3. Oh. Compare 1 and 3 and 1 and 2. 1 is the leader. 1 is the leader. Compare 1 and 2. And then the leader with 2 and the leader with 3. So when you compare 1 and 2, what do you get? 3 plus 4 is equal to 2 plus 3. What do you get? 3 plus 4 is equal to 2 plus 3. So 3 gets cancelled. So you get angle 2 is equal to angle 4. You will get more, meaning you can use AAA like this. This is enough actually. This alone is enough. But I'm just telling you the other one. When you compare 1 and 3, what do you get? Angle 3 plus 4 is equal to angle 6 plus 4. So 4 and 4 gets cancelled. You get angle 6 is equal to angle 3. So in the two triangles, that is in triangle ABC and triangle DEF, ABC and triangle DEF, what have you got? Angle 4 is equal to 2. Angle 4 is equal to 2. That is angle 2 of this triangle is equal to angle 4 of this triangle. Then you got angle 3 is equal to 6. Angle 3 of this triangle is equal to angle 6 of this triangle. And already we know that angle 1 is 90 degrees here and angle 5 is 90 here. So see, AAA similarity criterion. The two triangles are congruent to each other.
But we can do it only with 2, no?
Yeah. Correct. That's what I said. Yeah. Comparing 1 and 2 is enough. Comparing 1 and 2, you will get one more information which you need. That's enough. You don't have to do both. You can do with AA itself. Not that you have to do AAA. I said you have information for AAA also. Yeah. So again, this is important, children. Yeah, I've done both the methods. Since it's time, children, just take a screenshot and complete it. See, you can see method 1 here. You can see method 1 here. Pointy lines or supplementary lines are parallel and then all this. Then this is what I explained. Okay, which is the master rule. 3 plus 4 is 90 is the master rule. 3 plus 4 is 90, which is here. 3 plus 4 is 90 because 3 is in one triangle, 4 is in the other triangle. So we'll be comparing A and B with C. A with C, B with C. All right, children, take a screenshot. Complete 9. Complete 9, 10. And 11 because you can see it here in this slide. So please complete the 11th one also. All right.
Yes, ma'am.
Yes, ma'am.
All right. All right, children. So that's it for today's session. Thank you. Good night.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you, children. Good night.